All right, well, I'm going to go ahead and get started. Welcome to today's Globe Observer Connect. We are so excited to have you join us today. And this is kind of a different one for us. We are delighted to be able to talk about Artemis and the moon and talk about how that compares to our observations of Earth and why it's important to study both. And so we're thrilled about that. As a reminder to everybody, we are recording this, so if you're uncomfortable being on camera or having your voice recorded, please feel free to interact in the chat and keep your camera off. Otherwise, I'm going to hand this over to Heather to introduce our guest speakers today.
Sure thing. So, hi everyone. You might not immediately recognize me. My name is Heather. I'm on the Globe Observer team. And a big part of my role is actually working a little bit more behind the scenes on creating some of our communications and outreach materials. So, if you helped us out in collecting data during the eclipse and remember some of our flyers and postcards and videos from the eclipse, that a lot of that was my work. And what was really cool about working on the eclipse was that I got to collaborate with people from the heliophysics division, which studies the sun, and the planetary division, which studies the planets and moons in our solar system. And it was actually through a planetary colleague that I was able to meet Amber, and learn about her really, really cool job. And so Amber and Megan are both members of the Artemis II Lunar Science team, and a big part of their role was actually preparing the astronauts for their historic lunar flyby by training them on how to take those scientific observations. So you might be wondering, that's awesome. What does it have to do with Globe? But while I was watching the Artemis II coverage, I was really struck by the fact that the astronauts, what they were doing, felt really, really similar to what you all do when you use the Globe Observer app. You're going out, you're observing the world with your eyes and cameras and making really valuable scientific observations. And as you know, NASA has really awesome satellites and orbiters that are collecting data on the Earth and the moon. And it goes to show that there's a lot of value in having both that really cool data from our instruments as well as human observations. So I think that's enough for me. And now I'd love to hand it off to Amber and Megan to talk about their experiences with the Artemis team.
Thanks, Heather. Hi, everyone. It is super cool to see some of you dialing in from Greece and Peru, and I think I saw Brazil in the chat, so that's pretty awesome. I'm going to share my screen because we've prepared a little presentation for you all. So thanks for having us, everyone. My name is Amber Turner, and I'm presenting alongside Dr. Megan Borel. And today we're going to talk about our roles during the Artemis II mission. So Megan and we're part of the observation planning team, which is a subset of the Artemis II Lunar Science team. And you probably saw us working in the science backroom of mission control. And Megan and I were directly responsible for drafting up the crew's science plan before uplink and providing real-time science support for them while they were in space. And in addition to our roles in mission control, we're also part of the crew training team. And we're going to talk about all of those things in the next few minutes. So as many of you likely followed the mission, you'll know that the Artemis II crew's science objectives centered on capturing images and making recorded scientific observations of lunar surface features, the lunar environment, and deep space. And the specific things we asked them to image and describe are called targets. So the lunar surface targets map to broader science themes that I'll get into the next slide. And before I get to that slide, I wanted to point out these flight tablets that the crew are using. these are their onboard science documents that Megan and I actually helped develop. So it was super cool to train them on these things and also actually see them using it during the mission. And so now I'm going to get into the science themes that their science targets trace to. So you don't have to memorize any of this. It's just to show you the kind of range of things that we wanted them to image and describe. One of those things is, for example, color variations in different basaltic lava flows on the moon, different tectonic structures, the lunar environment in deep space, and craters and things of that nature. And so, as I mentioned, Megan and I are responsible for helping the crew prepare to execute their science objectives, which was to image and describe the things that I showed on the previous slide. And to do that, we helped develop 2 different onboard flight documents that were shown in those images with the crew a few slides ago. The one on the left is called the Lunar Targeting Plan, and it is their real-time reference document for navigating their science objectives. And Megan and I developed this document with a full team of software developers out of Johnson and scientists from all over different NASA centers. But we were directly responsible for mapping the boundaries of the targets, so like showing where the basins and craters end, for example, and giving the coordinates to the team to develop their lunar targeting plan, as well as writing up the observation actions for the crew to follow with the camera and for their verbal observations. And so the example that we have here on the left on the lunar targeting plan is the observation actions we wanted them to follow for Oriental Basin. So you guys probably saw all the famous Oriental Basin images. And so this was the plan that led to getting those images. And what we wanted them specifically to do is to describe how the different ring mountains looked, the color variations that they could see in the different types of lava flows that are in the inner rings and in the center of the basin. And on the right here, we have the Lunar Geography Review, which is another document that Megan and I helped develop, which is a reference or study document that they used prior to the lunar flyby to help orient them to where things are on the moon. And if we had a little more time, I'd dive more into like kind of the reminders that we gave them for their science objectives. But I will leave it here and pass it over to Megan to talk more about the imagery as well as the science training for the crew leading up to the mission.
Hey everyone, my name is Megan Borel. As Amber said, we both were part of the observation planning team and the crew training team. So as Amber mentioned, we worked together to create the guidance for the astronauts to complete the science objectives that our science team had. So now I'll walk us through some of the images that we got from Artemis II. So on the top left, you can see the view of the west limb with Oriental Basin really showing off in the middle, kind of middle center, south center. Yep, there you go. And this is the first time that human eyes have seen Oriental and much of the west limb in sunlight. So although the Apollo program saw much of the moon, a lot of this part of it was actually not in sunlight. So they weren't able to see all of the features and especially Oriental Basin. The next photo on the top right shows the Terminator, which is the change from lunar day and night. And you can see its distinct morphology along it. You can also see the difference between the top 2 photos. The left image really doesn't do the Terminator justice. You can't really see that really distinct and clear morphology changes that the top right image does. And the morphology is really visible as the Terminator shows like the the shadows inside the craters, along the crater edges, along the central peaks, all of these different features that the moon has. You can really see it as the Terminator crosses into new spaces. So it was really, really cool to see those close-up images of the Terminator. I'm sure everyone has seen the Earth image, our Artemis blue marble. The things that I like about this photo are the two auroras. You can see the northern lights are on the bottom, and then the southern lights are actually on the top. You can also see the zodiacal light coming in on the bottom right. And we have to include our Earth image because it's amazing. And since you guys are globe observers, I'm sure you guys can also appreciate that and probably already have. And then the last image of the incredible eclipse, this shows the eclipse image, the full entire eclipse, and also shows a lot more that our science team really cares about. So some of those science themes that the eclipse image was able to show us, like the lunar environment, the deep space, the lemon terminator morphology, and it also gave us a lot of hope for impact flashes. And you can't obviously see them in this image, but this image is really, to me, encapsulates the Artemis II mission, because first, if we would have launched on any other day, it's unlikely that we would have had an eclipse. So it's very special for A2. And also it shows like 4 out of, however many 10, I think, science themes we had in one image. So I really love that eclipse image. You can go to the next slide, Amber. So Amber and I have interesting roles on the science team in that we also do crew training. This was particularly valuable for our observation planning roles because we were able to build the terminology, the concepts, and the different features that we help to train the astronauts in during their lunar science training, which directly puts those connection and those features and that exact terminology into the software that went on their tablets and went up to space. So it really brought like a cohesion that linked the training to the operations to the rest of the science team as a whole. And I really appreciated that kind of connectivity between the crew training and the broader Artemis science team, which you can see down there on the bottom left. We're just a small part of a large team. And the rest of these images are of various training events at Johnson Space Center in Houston, where we train the crew in things like photography practice, just looking at the moon, kind of getting themselves oriented to different features on the moon, any main geographic and geologic features that we like to teach them about, and also learning the tablets and the software that Amber and I helped with. I think that's it for this slide. Can you go to the next one, Amber? And thank you. We would love to answer any questions you have, or whatever else is next on the agenda.
Yeah, thank you all so much. I love the picture you ended on. Hill that Rise is just sort of like watching them, like, oh. So if people would have any questions, please feel free to drop those in the chat. I can start because I have so many questions. Oh, we already have one in the chat. So I'll go ahead and read that one to you all. So they write, greetings from Greece Globe V School and Tiny Core Lab team. How do the scientific objectives and the data collected during the Artemis II mission relate to or complement the global climate monitoring efforts of programs like the GLOBE program? And what are the potential synergies between lunar exploration and terrestrial climate research? Would it be interesting to take ground-based observations during a full moon at solar noon? Would there be any difference in the measurement results, like the effect of temperature from the lunar sunlight reflection or the increased soil humidity due to lunar gravitational forces? Thank you.
Amber, do you have any thoughts on that one?
I might actually pivot to our globe colleagues to help with the connector there, because we were mostly lunar science focused. We did appreciate and have a plan for them to, like, we wanted Earth observations as well, but I think I'm going to lean on the true experts here for that one.
Yeah, that was a super interesting question. And I certainly don't know the answer. But that would be a really interesting thing to dive more into. Um, so yeah, Holly, do you have anything to add?
Um, I can't answer fully, but I think one of the things that really struck me as you were talking was the universal process of science. They're really thinking about what you had limited opportunities to collect data, and you really focused on the things that were going to be the most interesting to you scientifically, and then created a process, a plan for collecting those observations in that very limited period of time, and then to get the most out of them. And I think in the Globe community, you guys do the same thing, particularly those who are working with students or leading volunteers in other ways. You have to think about what you want out of your data collection. You have to plan it. You have to go out and collect that very specific data and then have a plan for using and monitoring the data. In terms of the broader scientific connections, I'm sure there are very interesting things that can be learned. Um, I am not a researcher in that area, so this is just me speaking about things I've heard around the halls. I know that at times the moon has been used as a calibration target for some of the Earth satellites. That it's just a nice to help us kind of a nice consistent color and distance. If you know the timing, the distance, right? So I know that folks have used the moon as calibration before to help us better understand what we're getting out of our satellites. But I think there are discussions around the halls about other things we might do too. And I don't know enough about that to go much further, but I think there are some interesting ideas being thought about in the science community.
Mhm. Thanks, Holly. And sort of following up on how the data is being used, Marley posted a great question in the chat. How is the data of photographs and verbal descriptions being processed? Is it AI or ML being used?
I don't think we can talk about like the data processing methods, but I am excited to get a question about data, because it will be the images and a lot of the observations that they made during the mission will be publicly available in 5 months now. It's supposed to be 6 months post splashdown on the planetary data system. And so, yeah, all of that data is in the process of getting processed for public consumption. So you guys can look forward to getting access to all of that. But yeah, sorry, I can't give insight into the sausage making.
That's awesome. I'm really excited for that data to come out. Leanna asks, what observations captured by the astronauts were you most excited about? And was there anything that you weren't expecting?
Okay. For me, I might piggyback off of one of Megan's favorite uh, science objectives that she mentioned during the presentation. So the eclipse science objectives that we had were kind of like a total bonus. Like the fact that we were able to launch on April 1st afforded us the opportunity to not just get geologic observations, but also, look at the solar corona in the sunrise and sunset images and look at the moon in that way. And like, it was just, it was funny because in the sims prior to the mission, we kind of were giving the crew like a hodgepodge of lunar targeting plans that had eclipse imagery and geology on it. We were like, well, we don't know if we're going to get it. The chances are super low. So yeah, I was pleasantly surprised by all of the signs we were able to get, especially, you know, the eclipse images. And then I'll let
I
Megan.
think
Yeah.
my favorite, well, I shouldn't say my favorite, but one of the things that I was most looking forward to was the descriptions and the images of Aristarchus Plateau. I'm a geologist, so I was really excited about them being able to see Aristarchus because it's one place on the moon that's very geologically diverse. So I was hoping that they would be able to see different kinds of colors or maybe different textures and give us some insight into like a deeper insight into what is really going on in Aristarchus Plateau.
That's really cool. The next question we have in the chat is, I love the diversity of questions that we're getting. What programming language did you use in order to develop the software on the astronauts' tablets? Or if you know, it sounds like maybe that the development happened at Johnson with a different team, but do you know?
Yes, the team that developed the software, they're called the Crew Lunar Observations Team, and they are a subset also of the Artemis II Lunar Science Team. And that would be a great question for them. So I would definitely encourage Heather, if you wanted to invite them one day to talk more about about the software.
That's a great idea. Thanks. Um, And there's a really lovely response from Angelica in the chat that I encourage folks to read if you'd like to check that out. But please feel free to continue posting any questions that you have in the chat. I'm curious, what were some of the biggest challenges or maybe surprises that came up while you were training the crew?
Sorry, I might have to think about that one. Biggest challenges in crew training. Megan, do you have any?
Yeah, I can give a go at it. I mean, the crew are incredible and they're very interested in science, which helps our job and makes it a lot easier. But one thing that is hard is working on the science plan while also training the crew on science because we're doing this parallel training with our like development of the science plan, and it's hard to be able to say this is what we want and this is why we want it and give it to the crew at the same time whenever it's not, you know, fully done being planned out. So that was a kind of a challenging part, but it also in a lot of ways made us better because we were able to think about kind of from a crew perspective what types of questions they have, and then we can tackle that and then have this nice back and forth with them. Another thing is they've got very different backgrounds and expertise, so it's hard to make sure that everything is on the right level that they can understand. You know, we don't want to go too far into geology and lose everybody that's in our in our training, including instructors, because we all have very different expertise. So that's one hard thing of training, but it's also just as equally rewarding and like I guess, you know, positive in the way that we can interact with them and get a better understanding of what their mind is thinking about whenever we're developing and delivering the crew training.
Thanks. And yeah, that sort of reminds me, so from what I understand, the Artemis II astronauts are not trained in lunar geology the way that you two are. And it sounds like you were both teaching how to take those observations, but also why that's important, why they're collecting that observations. Is that right?
Yeah, and they were actually very curious about like what their observations directly would give us as scientists. So it was really awesome to have that like dialogue and different types of thinking towards the same science problem.
Do you feel like that improved their observations, that background knowledge of why they're
I was
important?
really impressed. Amber and I have had this conversation a couple times. Like they're like real geologists up there. They're definitely real scientists, and we were all very impressed. Like the science team as a whole, we kind of had these moments where we all gasped because we were so excited about what descriptions they were saying and how good of geology descriptions and science descriptions they were giving us.
That's amazing. Leanna asks, she's curious about the different ways that you'll be using the observation data. And then related to that, how do you use, for example, albedo data in your work as geologists?
So the science data that the crew collected, for example, color and albedo variations in, for example, like Oriental Basin, of the different types of mare, give insight into the material properties of what we're asking them to describe. And the color provinces and albedo variations of basaltic lava flow specifically give insight into different styles of volcanism. For reflectance properties or albedo of crater ray systems, for example, the over time, sorry, I'm getting a little distracted by the chat. Over time, we can learn about how space weathering affects crater ray systems over time using the reflectance properties that are observed in orbit of those ray systems. So those are a couple of examples. Megan, do you have any others?
Not off the top of my head, but if I think of any more, I will. I'm gonna think of them now.
Yeah, please feel free to come back to that question if you think of anything else. Sort of following up on that, something I've been really curious about is, I think one of the things that the science team was really interested in hearing from the astronauts was descriptions of the colors on the surface. And I do a lot of graphic design. I think about color a lot. And there's a game I really like where you have a big board of colors and the other people are trying to guess the color. You know a secret color, and the other people are trying to guess, and they have to use words to describe the colors. And it's really fun, like what words work better, which ones are very controversial, or there's, a lot of back and forth and arguing between the players. And so I was curious how Leanna's played that game. It is hard. I play it with a friend who's an interior designer, and we get really deep into arguments in that game. But I was curious how you prepared the astronauts to describe the colors. Was it just sort of wide open? Did you give them a box of Crayola crayons and be like, here are some ideas? Yeah, could you share any more information about um preparing them to describe the colors on the moon?
Color is actually a funny one. It's good that you brought that up because whenever we look up at the moon, we see gray. It's everyone's like, there's colors on the moon, I don't see any. But whenever you get up close, there actually are different colors on the moon. And they're also sort of similar. We definitely have the grays, we definitely have some blacks and shadows and even some whites from like really fresh impacts. Um, and so we had to really push for all of training. So we start as astronaut, the first crew training that they have, or the first training that they have even as candidates. A lot of it is just talking about what you see, and a lot of that is color. So we'll give them rocks, and they kind of start out gray, and they say, we need more than just gray. Is there like a light gray, a dark gray, a sparkly gray? Is it more tan gray? Is it more blue gray. We have kind of, you really start to get into the nuances of color and the spectrum of color for the moon. It's kind of like you might see some blue tints, you might see some green tints, you might see some brown tints. And so we really have to push them to say exactly what you see. It might not be the same as what your partner sees, and that's okay. But if okay, we see this light gray here, we see a sparkly gray here, you can start to train your brain to like really be detailed about what colors you do see. And that's another thing, going back to the observation data. As geologists, a lot of the different rock types are different colors. And so if the astronauts or the images show us different colors, then we can start to tie that to some of the other data that we have of the moon. Like, for instance, if there's a green spot, our geology brains automatically go to all of the common mineral on the moon. It's not always that olivine exists there, but it gives us kind of something to start with and something to investigate on whether those minerals do make that color change, or maybe it's something else completely.
Thank you so much. I love that approach of starting them rocks and pushing for more and more and more so that they can start to really train their eyes for that. We have a question from Holly. She's wondering, do you think your training helped the crew enjoy seeing the moon more or appreciate it more?
Absolutely. So as Megan mentioned, the crew on their own they were very excited about the science. They are very curious minds. They definitely enriched our training, just like in general, and gave us feedback on the different types of flight documents we were making them, and like asking pointed questions about the science plan and they were just overall very engaged. And we gave them a lot of autonomy when it came to their lunar targeting plan, and let them know that, like, of course, we have these things that we're interested in for our stations, but as members of the science team and as our eyes on the moon, you can make observations that are interesting to you. And they absolutely did that. And actually, like, on their way to the moon, they made a lot of opportunistic observations that were not on their science plan. So that was super, super cool, and speaks to like how excited they were from their training, but also just on their own. I think that they just make amazing lunar geologists. We really with this crew, they're awesome.
That's amazing. And that reminds me of some of the observations that we get from our volunteers. We sometimes ask for specific things to go out, look for, damage from hurricanes, for example, or wildflowers blooming in a particular area. But people also just share what's interesting to them, and sort of their own unique perspective. And that's always really fun to see when you're going through the database and just sort of browsing the data, is what everyone individually brings with their observations. Holly also writes, I wonder how much color they may have seen without your training. Do you have any thoughts on that?
Yeah, actually, in one of their training, Christina asked if they could look at spectral data of some of their lunar surface features. And in the spectral data, it shows the gradient of composition that might not be super obvious to the human eye from like a first pass. And it's not that we wanted them to memorize every single little variant of color in a specific feature, but it was kind of to give them that acuity and kind of let them know, like, in this feature, like, with some dwell time, like, we want to know if you can observe the kinds of color variations that we've been able to pick up in spectral data. So I would say that the training did help quite a bit, but also their curiosity in general. And it was actually the crew who asked us for the spectral data to kind of guide them in so that they can do a deep dive into their surface features. So yeah, kind of like, yeah, it was super cool.
Yeah, I was really surprised by I don't remember which basin it is, but I know in the Lunar Science Passport there was a comparison of sort of the I guess in our science at least we call it the true color, and then the spectral data, and there was this like streak in the middle that I was like, wait, what? And I kept flipping back and forth between the pages because at first glance I didn't notice anything different in that area that had sort of like the streak across. And so that was really interesting to see, and it's really cool that that actually sort of originated from Christina asking for it.
Yeah. Yeah. Love the whole crew. Love Christina. They make great scientists.
All right. I'm not seeing any more questions in the chat. If anyone has any last minute questions, I'll give it some time. But I had, one last question for our community. I was wondering if you have, we asked people to go out, observe the world around them. And I was just wondering if you have any general tips for becoming a better observer.
Hmm. I guess something that we tell the crew is the more you look, the more you see. And with dwell time, you can make really good comparative observations, like on a wide, like geographic scale. And to just, yeah, give your eyes enough time to adjust to something before you make observations. So you might be able to tease out details that your eye might not have been able to discern from your first glance. So just like part of being a scientist and an orbital observer specifically is really that dwell time and letting your brain sit with that quiet time and like really thinking about your first impressions.
Wow. Yeah, I imagine that was also potentially really hard for the crew. I know if I was flying by the moon, I would have been like, look at that, look at that, look at that. It would have been very hard to focus on one feature for a while, but that's amazing advice. Thank you, Amber. You have another thank you in the chat. Holly, did you have anything to add?
I was just going to also thank our speakers and tell folks about our next Globe Observer Connect. But Megan, did you want to say anything else to comment on Heather's question?
I'll do a quick one. As a geologist, we're kind of trained to observe patterns, and that's one thing that for the moon and for Earth is very important. The change in patterns can always tell you something about what's going on. And so that's one thing that I always kind of joke about as geologists, like we're just looking for patterns. So that's my advice. We're keep looking for patterns, keep looking for differences. And yeah, you guys are are already great observers. So keep doing good work.
Thank you so much for coming today. I have learned a lot, and it's just been a delight to hear from you. So thank you. And thank all of you also for coming, for participating in our Observe Like Artemis challenge, and for participating in Globe. Our scientists also say they appreciate seeing changes and differences in the things that you observe. So thank you. Our next Global Observer Connect will be the week of June, the second week of June, probably June 11th, but we're just firming up that date for you. We're going to have a little bit of fun with the World Cup. So, all you soccer fans and even non-soccer fans, I think it'll be a really fun Global Observer Connect. It'll feature Kevin Sikowski and Dr. Eric Brande-Colston at NASA Goddard. And they'll be talking about how the world plays and some of the different conditions in which the world plays soccer and other things. So I think it'll be a really fun one. So watch the Globe newsletter and the Globe Observer website to get the details about that. Thank you all so much for coming. Again, we'll post this recording on the Observer website, and we will see you all next time. Thank you.
Thanks, everyone.
Thank you.
Bye.
Bye.